Alright, the last two problems don't have any new material in terms of like formulas or concepts. It's just an application of what we've done so far. So in the first one, we are given this function f of x, which is equal to 2x over x squared plus 1. And then we need to find the derivative of that function at x equals 1. Now, in order to find it at x equals 1, let's firstly just find the general formula for the derivative. Because if I have f of x, and if I know what it is, I can just, f prime of x, I can just plug in 1, and then I can find the value, right? But before that, we need to calculate the derivative. What are we gonna use here? Well, that's a very obvious quotient rule. We cannot really avoid it here, so let's just get started. So that's our numerator, that's our denominator. What was the the quotient rule? Well, we take the derivative of the numerator first, and we multiply by the regular denominator, so don't touch it for now. Now, from this, we subtract, what do we subtract? We subtract almost the same thing, but this time we're gonna take the derivative of this instead of this, okay? So I'm still gonna have 2x. I'm still gonna multiply by x squared plus 1, but now I'm gonna apply the derivative to this one, okay? And then we just divide by the denominator squared. So that's x squared plus 1 squared, all right? Okay. I'm going to be quick with the derivatives themselves, like the simple derivative. So that's just 2 times x squared plus 1 minus 2x of, and the derivative of that is 2x as well. Then we have x squared plus 1 to the power of 2. All right. And from here, I just expand the brackets. So 2x squared plus 2 minus 4x squared over x squared plus 1 squared. And that gives us, if we combine these, that's minus 2x squared plus 2 over x squared plus 1 to the power of 2. All right, very cool. So now that we have the formula for this thing, we cannot simplify it any further. So I'm just going to leave it at that. But now I can plug in 1 and actually see what f prime of 1 is, okay? So f prime of 1 is equal to that thing, but I just plug in 1 everywhere where I see x. So minus 2 times x, so x is 1. Okay, I'm not going to write it down, right? Because minus 2 times 1 is just minus 2. Plus 2 over 1 squared is 1, plus 1 is 2, so that's going to be 2 squared. And that gives me 0 over 4. So interestingly, we have f prime of 1 equal 0. Okay, that's our first answer for part A1. Now, part A2 asks us to find the equations of the tangent and the normal, which means perpendicular to tangent, lines at 0.11. So that's a very interesting question because it actually ties the discussion back to the very, very first tutorial that I gave for the class, which was on pre-calculus. I don't know if you remember these like equations of a line that we did, but that's what we're going to be talking about here, about slopes and points and so on. So we're given the point 1, 1, which means that this is our like x1, y1 for some random point, okay? Now, the application of the derivative here is the following. You've probably, well, not probably, but surely heard that what the derivative at the given point gives you is basically the slope at that point, okay? So if f prime of 1 is 0, that means that the slope at x equals 1, which is exactly what we have, the slope is 0, okay? The m signifies the slope. So that's the tricky part here. You just need to understand that the derivative at a given point gives you precisely the slope at that point, okay? And from here, you just need to remember the equation of the line, which we've learned before. I think it was called the points slope formula or something. And that's equal to m times x minus x1. And from here, you just plug in the values, right? So y minus y1 is 1. So I write 1 equals m, which is 0, times x minus x1, which is 1. Okay. But now, of course, we're going to have y minus 1 equals, this whole thing will be 0 because we're multiplying by 0. Therefore, y will be 1. And that's literally your equation. I know that sometimes equations have more elements. In this case, it's just that the slope is 0, that it turns the entire right hand expression to 0. It doesn't have to be like that on the exam. Like, if you have more numbers, just leave your equation with the more numbers. In this case, it just happened that everything canceled because of the 0, okay? So that's the equation of the tangent line. And then he asks about the equation of the line perpendicular to the tangent, also called the normal line. So, you know what? I'm going to call this M1 for the perpendicular line. For the tangent line, I meant. And then you know how I've shown you this formula? Whenever you want to find the tangent of a line perpendicular to the current one, the new slope will be equal to minus 1 over the old slope, so M1. Now this is pretty interesting because M1 is 0, right? So conceptually, based on what I've shown you earlier, we could classify this as, an infinity, a minus infinity. But when we're talking about geometry and slopes, we don't call this infinity or minus infinity. We call this a vertical line with no slope. I'm not going to write the whole thing, but basically consider the line to have no slope. So the way it will look is, so in this case, because it's a vertical line, we won't have any y in the equation. Y could be any point. It's just going to be x equals 1, right? So the equation of the line would be x equals 1. Now you're probably wondering, where the heck did that come from? Like, how did I think of x equals 1? Well, I know that the point it passes through has a coordinate of x equals 1. So it has to pass through, x equals 1. And then we found that it has no slope. Okay, so if it has no slope, the slope is division by 0. It's a vertical line, so the only choice that I have for a vertical line is to passing through x equals 1 is like that, okay? And the equation of that thing is always just x equals 1, all right? Just a vertical line that passes through x equals 1. So that's pretty much it for this problem. It's slightly longer than the other ones, right? But as long as you understand how slopes and derivatives are connected, you'll be fine, I believe.